The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian volcano tracker update. Today, Thursday, December 8th, 2022. It's day 11 of the Maunaloa eruption from the Northeast Rift, Dane. Big changes reported overnight. We've seen these developing over the last couple of days, but they've come to a head today with lava output from the vent reducing significantly. The channels that are downslope from there draining out, so no longer feeding that longest flow. That flow has stopped coming towards the highway. I mean, that started yesterday, but now it's all the way stopped. It's just settling and maybe expanding its footprint just for that reason, but otherwise that. And up at the vent, let me switch our preview image here. Up at the vent, we have had massive changes today with higher fountains than before. Likely that vent nozzle is getting a little clogged, so it's shooting up in the air higher. So that's built up the cone quite a bit. It's forced lava up from the middle and blocked its channels and forced the lava to divert outwards. So all of it kind of related to that drop in output and, relatively speaking, increase in gas relative to how much lava is coming out. What strikes you as, of all those options today, what strikes you as the most interesting thing, Dane? I cannot hear you.
Oh, sorry about that. Yeah, I was saying the channel diversion really seems like the story of the day right now, because it didn't just reset, a mile up from the flow front. This reset it all the way back up to the top, right back at 11,000 feet. So it's going to take it a while to get back down to that flow front, which is now just becoming more and more viscous down there, just a giant blob of lava that's a mile wide front of a.a, but no longer really advancing. There is some creeping to it, but we'll get into all that.
Yeah, and it's an interesting question about whether this diversionary flow that's been created now from the changes at the vent actually can make it down as far as the last one, right? The last one came out when lava was still hot and fluid early on in eruption, and we expect this is following, and everything from USGS has been sharing, we expect this is still following that pattern of the lava growing more crystals before it's erupted out, so it's more viscous coming out of the actual vent itself. So the actual source of the flow could be more viscous, and they might not make it as far just for that reason itself, and that's another giveaway that the flow in eruption can't sustain itself any longer.
Yeah, definitely interesting.
So yeah, that's what's on our menu today. We'll track through everything here. There's quite a bit to talk about. Kilauea is still crusting over and doing its thing similar to the last couple of days, but no real development there. We'll check in on it a little bit later as well. And we'll talk about the why with the crystals and the gas and all of that as we kind of go through. So, nothing else, Dane. We'll get into it here. And
yeah, I think that'll be it for now. If anybody does have questions, we'll try and actually do question and answer this time. We lost it last time because the power cut out, but this time we'll try and get through it.
Yes, thanks. Yeah, short memory has so much going on, but yeah, yesterday, apologies. My moment of fear when I saw all my electronics click off simultaneously in my house. I was like, oh, I guess we're done. So apologies for that. That didn't quite end as we had planned. We didn't take the questions, but we'll make sure to do that today. So mahalo for you guys. So, okay, what you guys see here on the screen is just a little clip of that MK2 camera from last night. The weather has been challenging, so you can't get continuous views through the whole night, and we're just clipping what we can from little moments. So this is early on in that sequence, after we had stopped our update yesterday. But what you can see is that these lower parts of the flow down in here, I don't think I have my brush up, the lower parts of the flow down there are just showing glow at the edges, and so those are establishing new flow paths. There's not a channel there to really deliver the lava. It's really spreading out and fanning out and hardening in place, and it's maybe trying to form some kind of tube system to go a little further down, but it's really not getting as far because of that reduced output. So let me see if I can get my brush working here. Just a second. Brush and... all right. So there is those areas of... there is those areas of flow like that. Another path coming down this way like that. Right? So let's clear this. Try it again. One path coming down this way and another path coming down that way like that. But as this video loops around, you can actually see up here at this upper part that right in here, it seems to be withdrawing back to that point. So lava is so little that it actually is not able to occupy the channels. The channels are draining out, less is coming in and is going downhill here, which is why you're seeing these areas go dark. And then it pulses, there's another pulse coming down. What this is telling us is that the vent is undergoing the cycles of more lava coming out and less lava coming out, more coming out, so it's kind of surging is another way to put that. And that's something we also saw in 2018, Dane, in the later stages of Ahu'ela'au, also known as Fissure 8. In that case, it was a few weeks ahead of the eruption ending. We started to see those surging events. And so this is a different eruption, different volcano, but similar pattern. It's not quite clear how long it'll be before this phase ends here, but this is consistent with all historical eruptions of being the beginning of the end phase here, when a volume goes down and the flow fronts retreat back up the hill. At some point, it retreats all the way up to the vent, and then the vent clogs itself, and that's the end of that. So that's what we're looking at here. That's that summary of that view, and then let's just quickly show this one again, and we'll show a slower version of this coming up, but in case you're wondering, there is a high fountain phase overnight, and you notice these areas in the middle of the cone, right in there, and on the sides, this whole rim on the right side has been rising and growing. And we actually can see the original river of lava flowing right through here. And you see this, all this mass seems to be growing and slumps down into this channel area. And then we see a big flow come out in this direction over top of there. Right? It's all happening pretty quick there, but that's one way that this mouth of the outlet can get blocked. And then this channel would then drain out somewhat. There's still some lava going through there. We heard from Dr. Han yesterday that the estimated depth for these channels could be up to 4 meters, 16 feet deep or so. So that gives you an idea of, it could drain partway and not be visible on camera, but still have a little trickle going through there. In any case, a lot of massive changes here, and that's why it's diverting the flows. Related to more gas coming out, the extra gas can mix with the lava and make it a more gas-rich fluid lava, essentially a Pahoehoe phase that could be flowing near the vent here, but not getting as far because there's less lava there, right? So that's the interesting thing here. We'll look at that and see what kind of clues and see if we can confirm if there's some Pahoehoe there or not. It's hard to tell just from these camera images, but that's the pattern that we see in historical eruptions. So let's go to the USGS update. The first one from 8:40 a.m. today. Still at alert level warning, aviation color code orange. And they say, the northeast rift zone eruption of Maunaloa continues with a major change overnight. The Fissure 3 vent continues to erupt, but the supply of lava appears to be much reduced this morning. Lava is overtopping channels near the vent, with flows extending no further than 2.5 miles or 4 kilometers from the vent. Channels below this point appear drained of lava and probably no longer feed the main flow front. As of 5:30 a.m. today, December 8th, the flow was stalled about 1.7 miles, 2.8 kilometers from the Daniel K. Inouye Highway, Saddle Road. The lava flow is now inactive for most of its lower length, but the flow front may appear to advance a little as it settles. At this point, they had measured 120 tons per day on December 4th, is being reported here. The report tremor is ongoing, and everything else is standard here for this report. The major changes already noted up there. And following up on that, the report that just came out about a half hour ago here, 4:46 p.m. The changes here, they say the supply of lava was reduced this morning. Lava was overtopping channels near the vent with flows extending no further than 2.75 miles, 4.4 kilometers. So it's going a little bit further, but it's not nearly the 10 miles we saw for that other flow. It's still got a long ways to get back to there. We'll show you a map here shortly. The channels below this point appear drained of lava and probably no longer feed the main flow front, which remains stalled at about 1.7 miles. So there is that same information, and we have a new measurement of SO2 of 130 tons per day on December 7th. That's yesterday. So as of yesterday, the gas coming out was about the same, maybe slightly more there, right, than we saw that previous few days before that, 3 days before that. But the big change we're seeing today, I'd be interested to see the measurement from today and to see relatively how much gas is coming out. And it's interesting because often the gas and the lava are tracking each other over time. But there can be an end phase of eruption where you have more gas than lava disproportionately. Maybe you have like an extra buildup that finally gets released because the lava conduit is relatively cleared compared to before. That's not quite clear. We'll have to wait for more information on that. So that's the text reports. There's one other thing I wanted to bring up, and this is a USGS tweet from this morning. And they're noting that the live stream is still on a fritz, but they do note that on an M8 webcam, lava fountain heights grew overnight, sending lava between 200 and 500 feet above the vent. So 500 feet is 150 meters. That's the height that you're looking at there, right? For the highest fountains of lava. They actually had to zoom the camera out, so we'll show you guys that version there. Not only that, they have other images posted in here that will also, that's the number I wanted to pull out from here, 500 feet heights of the fountains overnight. So next I'll show you guys a map. Here is the map from the USGS from 10 a.m. this morning. And there is that regular pattern. You probably can't see a lot until I zoom it in. There's the flow front, that little sliver of red right in there is how much this flow front has settled. Essentially it's gravitationally settling there. It might be slightly fed by lava, but all that stuff still has a fluid core and it can basically settle under its own weight and expand its footprint slightly that way. But it's not really making progress like it was before. That's the very furthest flow front. There isn't that one that branched off yesterday, slightly upslope on the east side. showing slight progress as well, but also stalling, and same thing for the other overflows here on the side. And that zone of overflows, if I scroll it back up to here, there is where they're marking a flow breakout. This is the Maunaloa Observatory Road coming across right here, so it's actually above upslope of the road, right? And we're looking at, in this map, it's at elevation of about 10,000 feet or so. So the flow is coming down from 11,500 down at 10,000, not nearly the distance or drop that it was coming before. It's still impressive. This whole thing is massive, but compared to what we just saw, it's definitely a lot smaller and reduced there. So since this morning, it might have gone a little bit further. It seems like they advanced the distance a little bit, but so maybe in a range of somewhere in here, 9,000 feet might be where the flow is actually coming to now. So they're zoomed out, the fissure, and that flow front as of this morning. Okay, there is that map. And so we also have a thermal image. This one goes back to yesterday morning, but we had started to see the channel breakdown by that point in time with overflows. So here in a thermal image, there is that main flow front still hot on the edges where it's still oozing out from the edges as it settles. That feeder channel is visible on here as a little bit yellower, brighter signal, but it's not as hot as it was. Some of this area can be dispersed heat because of the spreading nature of the outflow, but it's definitely reduced compared to what you see upslope, where you see these two channels on either side. There is that eastern branch and the western branch that have been coming down on either side of that main channel right through here. You can see that easily in a thermal. More easily, maybe if I can zoom it in. I'm not sure how much. Zoom it in, I think that's it. So right there in the middle. And then the redder areas are that hottest lava that's got an open surface, and you see a bit of that here and here. But overall, not as much red as we've seen in some of the previous images. And more so when you get closer to the vent. There's a vent, and there's that upper channel flow that seems to still be red and hottest. So that's the zone that's being sustained by the eruption more so now, and less so the area below that observatory road. Given these breakouts are what we showed you guys, retreating up as a surge ended, and there is a reduction in lava coming down a slope. So those are the maps. Let's go to some of the visuals. Let's check in on the live cam from UH 2.2 meter telescope. And we have a zoomed out view. There's what it looks like. Looks like some low cloud covers coming in from the helo side, but not really spanning all the way across. And clear at the summit. Looks like it's going to zoom in at a convenient time for us. And there you can still see some gas coming from the vent, but maybe not nearly that giant plume that we saw coming up earlier, right? So it does appear visually that there's a reduction in the gas. It's definitely not shut off, but it does appear to be less robust than before, just visually. So that's the UH camera. Let's see if the USGS Live is up, and I think probably not. So, oh, no, it is coming up here. There's
it's up again. Yep,
back up, there it is. So at present, there is the fountains that are bubbling up. There's an occasional splash. That splash got up to right around here, around that horizon. But overall, it seems to be below the height of this right side of the cone. That's just for reference now. And then we can go back to, let's go back to the M8 camera, which even when that live is going down, we're getting captures from this M8 camera. So there's one from earlier today when the content was a little bit lower as well. And let me reload it, and it'll reflect what we just saw in the live there. That low burst. I've mentioned the scale is really hard to judge here, so there's a couple of things I can show you guys. This is one image that USGS posted today, and the same image there, and we zoom way in, and there is the USGS scientists right there, two of them, and they're on the back side of this cone. This is a side that's not getting nearly as much spatter. I've got some occasionally. Maybe they're there to pick up some chunks of it, and if so, they're probably looking very carefully to make sure that fountain wasn't changing direction or height or anything like that. So zoomed out, there they are right in there. That's a person, and that's the size of that, right? So if that's shooting up, the cone itself, roughly 100 feet, it's grown. It's been growing, so it might be a little bit taller than that now, but fountain's maybe 200 feet there, and you can see the people for scale there. That's one version. Then we also have this other image posted by the USGS, which shows the people getting picked up by the helicopter. And the helicopter is coming into land, and you can see how close it is between the people and a fountain there coming in to pick them up, so they don't have to traverse any of this sketchy terrain here and So some professional work there to fly in there, and in those conditions, there's a little bit more zoomed in. You know, the helicopter coming up against that fountain. So that's pretty cool. Let's go back to this original video that we showed you guys. So I have this, yeah, let's have it zoomed in. Let me start it over here, and let's start it out. Start it out, zoomed out. So this is the slower, wider angle view. They've changed the camera zoom, so I've tried just put it together best as I can here. But there's that high fountain phase overnight. And you can see that flow actually surging, overspilling its banks. And then here comes that next flow out of the side to the, see the cone kind of slump in the middle. So that's the wide view over there. Let me zoom it in as far as it'll let me. And you can see that bulging happening here. See that hillside growing right in there. And then everything collapsing and settling back in there at the end as it loops around. So this is yesterday evening, coming in overnight. You can see how much this material is really projecting into that feeder outlet, right? That spillway. And look at that. It's growing on this side, it's growing on this side. And then afterwards, it all sags back down. And you know, Dan, this reminds me a lot of that gas pistoning we've seen and pits on Kilauea or other eruptions where, you know, as we heard described for the Fissure as well, right? You essentially have more separation of the gas and the lava. So you have a big column of gas that's mostly gas and one that's mostly lava. And so when it's mostly gas that's coming out, it's shooting up a whole bunch of gas and it's throwing the lava really high in the air. But then once that phase ends, then you see the lava itself coming pushing up, and that lava is degassed. So it's a little bit more viscous and sticky, and it's trying to flow back down. And that's what the size of the stuff seems to be made of to me. They're not really flowing away that much. They're just kind of growing and mounding up in place in a lot of these cases. So that might be what you see with some viscous lava pushing up through that vent, right? And then getting cleared so that more gas and lava can come up behind it. Really dramatic changes there. You see the landscape's changed quite a lot. And remember the size of a person, as I just showed you guys. To imagine how much this hillside's changing, and you know, look at the flow rising in height and spilling over, and then the channel getting blocked, coming over in this direction, and then everything opening back up and reopening the pathway. So it's really some crazy stuff happening there. We'll have to keep updating this over the next day or two to really continue telling the full story.
Yeah, that thing is really chaotic, that vent. There's so much going on in there, especially with the high fountains building up that cone so fast and then feeding back into it. Almost looks like it's, to me, it almost looks like it's part of the cone, that inner part is sitting on a liquid base, and that it's ebbing and flowing with that, the height of that as well. It's really interesting.
Yeah, you see it sag, you see it kind of bulge and sag a little bit, right, as a fountain increases and decreases too. So yeah, absolutely.
Yeah.
So
really interesting.
Easy to understand how if one chunk of that, if the level drops and a chunk of that settles in a little further, how it could clog the vent and shrink the nozzle, right? And it's just like having a garden hose and you have the hose coming out with you know, nothing on the end and it's just pouring out, but you put your thumb over that and you narrow that opening and then it'll start spraying out a lot farther and higher. So similar idea there. You don't have to reduce the volume at all to just have the nozzle shrink and have it shoot up. So even with reduced volume, which is what we're seeing from the actual whole channel system draining out and not being replaced by lava as fast, you still can have that higher fountains because of the nozzle and because of this gas-rich phase that we have at the end. So really interesting that you'd see higher fountains. You might at first think, oh, high fountains means more lava is coming up, and actually in this case it's the opposite of that, which is a little counterintuitive, but hopefully we explain the components of it there, right? The fact that there's more gas to lava, higher gas to lava ratio there, and the channel is draining is what really shows us the rest of the volume output reduction. So I thought this was really cool. I'll zoom it out one more time here and let you guys see
that's a really
wider
good one.
view.
You can see how that the cone itself is what is almost restricting that nozzle, because it's coming back into that center. It's not like a boulder fell off or anything like that. It's the whole cone is just getting pushed back in there. You can see it
slumping and sliding in. Yeah, it's like still like semi-plastic, just sliding in. Yeah, so really fascinating stuff there. yeah, so that's, this is the cool science of it there. Really, the impact of people is less now because that flow that was approaching the saddle road is stalled, so we can continue exploring the cool science and the evolution of the vent system up here. Right, so while things are changing at the vent, this is typical of the end stages of eruption, of other eruptions, like I've said before. And even though the flow type might change a little bit, it seems like it's not likely to get as far. That's also typical of many of these eruptions of this class that we're seeing here. So, all right, that's that out view. And what I'll do next is just play this couple of these compilations of the channel here. So this was a couple of videos USGS released. One was from yesterday and there's from today. So there's a today, this channel drained right here. And there is a flow, but it's further over. So there's yesterday with that main channel full of lava. And then today, that one drained, and here is that flow diverted from the outlet of the cone there. And so it can be making new flows, but they're not in established channels. They're having to reestablish that whole pathway. And they're not making it as far from that viscosity. So that's the couple clips from the USGS video. Dan's got a longer version posted that you can see more detail there. So bring that up in a bit too. For now, I want to move on to a little bit of the science behind why this happens, and show this graph before. And this is a generalized summary of what's happening there, right? So across eruption, this is 84. The temperature and composition of the lava stayed constant the entire time. The amount of gas coming out went up fast at first, kind of stabilized, and then went up fast again at the end. So it looks like we're now in this end phase. The abundance and size of microscopic crystals went up. So that's also what you see here, going up. And on the flip side, the discharge rate, how much lava is coming out of the hole, came out, it peaked early on, decreased, stabilized, and then started crashing here towards the end. So yesterday I was asked this, and it seemed like I was in this middle phase right now. And now it looks like we're coming on to this end phase, actually. So a big change from yesterday to today. Seems like the discharge rate is dropping, and along with that, the density of lava also drops, and that's a result of this gas, extra gas, and having it mixed into the lava as well. Right? That's what makes the biggest difference in lava density, is how much gas is mixed into it and before it solidifies. So that's the big picture pattern, and I'll go into a little bit more detail than I have in the past today. Here's a sample of spatter, and this is the same length of the eruption on the bottom here, and this is grams per cubic centimeter on the left, so it's just the density. And you can see early in the eruption it was higher, and then it kind of decreases. It's not, kind of randomly, because it depends on which chunk of rock gets thrown out you actually pick up. But their overall trend is a downhill, that decreasing trend. And you can see that the spatter samples that came out in that late phase of the eruption are around 0.5, 0.3 grams per cubic centimeter. That's, you're looking at half to a third of that of water, right? So really light, fluffy stuff there, and there is that 1 gram per centimeter that marks water. So you can see a lot of these are actually in that lighter end. So that's interesting for the spatter. And they took samples from the channel as well. And even in the channel, they saw that early on they had a set of values that were a little bit in that ballpark of 1 gram per cubic centimeter, a little bit higher, one a little bit lower here. But then towards the end of the eruption, it really drops off quite a bit. And it drops quite a bit to even that lava from the channel was down at 0.4 grams per cubic centimeter. And as the eruption waned off there in 1984, that gas content reduced, and thus the density increased there at the very end, but still all this stuff less dense than water, which is interesting there. So temperature over the course of the eruption, here's that graph. It's pretty much constant all the way across. So not going to dwell on that any longer, but here's an interesting other plot, and this is just from, I believe, April 2nd of that eruption, a particular day. So here's time in minutes at the bottom. We've changed the time scale. And what they're showing here is fountain height in this upper blob, this upper line, and down here, depth of lava in a channel. So even in 1984, they saw this variation in the surges where they'd see the fountain height would be steady, and you'd have a steady lava channel. The fountain height would drop, and then you get extra lava in a channel, And then when the channel level dropped again, the fountain will go up. So you see they're kind of taking turns, right? So that's this kind of surging pattern once again. This is early on, so we don't have the information over the larger time scale. But interesting to note that what we just saw in that video as far as the surging, and also similar pattern at Ahu'ela Fissure 8 towards the end there, where the fountains and the surges were kind of taking turns there. So interesting to note all those relations there. One thing I've mentioned is the crystals. So here are some samples of these of lava rocks they've taken and cut really thin and polished and put through a microscope. Put in a microscope so you could see. And so here are progressive slides that they've taken from different times in eruption. So early on, you see the big white circles, those are gas bubbles. And all this grayish stuff is volcanic glass. That's the lava cooling so fast that it's not having time to grow a whole bunch of crystals in there, right? And it's coming out hot and fresh early on. When you move a little bit further through eruption, you see these white lines in there. Those are crystals. Those little crystals starting to form. And there's a whole bunch of them, but they're not that big yet, right? You still have your gas bubbles are still there in good concentrations. And you also have some of this other, what they're calling, forget what some kind of dust. I forget what the term is now. It's escaping me. But these are the size. So the white crystals you see through here, those are the ones that are growing in the magma, and it's growing because the gas is released from the area and it changes the conditions. And so essentially that lava that was at equilibrium is no longer at equilibrium. It's undercooled, and then that allows the crystals to start growing in it as it starts to essentially harden and solidify the components that can do that first. So that's that second slide. Here's 3 and 4. You can see how much more those crystals grow over time. They get bigger, there's more of them, and they get a lot longer as well too. Right, so you can imagine, and look at how few gas bubbles. There's a gas bubble in this one, but really, relatively speaking, a lot less gas per area than early on in eruption. And so these crystals are the ones growing underground, underneath the vent area, and being brought in lava out that way. And some of these other darker spots, that's what you're seeing growing between the vent and the end of the flow on the surface. So you do get some crystals growing from lava cooling by running down slope, but this main phase of what's making it the bulk of it, of the volume here, is actually stuff growing underground underneath the vent as eruption's happening. Right, and to show this once again, here is this combined plot. I got time on the bottom, and I'm going to zoom it in so you can see it there. And this is the amount of crystals in volume percent of the whole rock. So from 0, and we're up to 30%. Early in eruption, very little, it kind of came up, and by the end, it ended around 30% crystal volume, that whole lava, which is pretty interesting, right? 30% crystals, 30% of that glass, and 30% of the gas, more or less. This down here is the length of those crystals, and so not only do you have more crystals occupying the volume, it's doing that by actually growing them longer. So this is longer in that direction. So you see them get longer, and then you also, once that stabilizes, you're getting more of them as well. So those are the changes documented in the graphs. And combined, that change in gas and change in the crystallinity is what's making those blockages occur. And once you have one blockage occur, that drains the river of lava below it. Once that river drains, the banks that were supported by the lava flowing through there, because lava is a liquid rock, and it has that same capacity to hold up other mass like a rock does. I mean, it has a relative density and all that, of course, but once the channel drains, then the banks likely collapse in a lot of places. And when the banks collapse in, that gives you more material that's flushing down lava boats. And that's what creates blockages, creates more channel diversions, and the whole thing starts breaking down and kind of starts domino affecting itself, right? Cascading effect of the whole thing breaking down. And that's what we've really been seeing in the last couple of days here. Really accelerated overnight. And today we're seeing collapse all the way up to the vent, essentially. So this was 84. And you can see those first few days of eruption, first about a week or so, and no blockages. And then they start seeing blockages, and what they're looking at here is elevation of the highest overflow producing blockage in the main channel flow. Right? So the highest one. So no blockages. The blockages start off. So noteworthy, the vent in this case is up around just below 3,000 or 2,900 meters or so. And you see it's about 1,000 meters down, 3,000 feet below that, you get that first blockage. And after some time, you get a blockage slightly uphill from there, then slightly uphill from that, and slightly uphill from that, and higher, higher, higher. And eventually, when it gets near the vent area, then it was pretty close to over at that point in time. So it's interesting that we've seen migration of the blockages essentially close to the vent already. It's hard to tell whether that's the main channel or not. We'll have to see more imagery of the entire channel, right, to see if we classify that the same or not. But in any case, we can certainly see from that first image that we shared. Pull it back up here. This one right here. Now we're having blockages all the way up to here. And so that's really high up there, and it's, you know, maybe not quite all the way to the vent, but it is getting to that point where it's approaching that elevation event. So we're somewhere in this end phase, somewhere through there, right? So that's why it also seems to be another indication the eruption is approaching its end phase here. Okay, a couple more quickly. This is a plot of parent viscosity on this side, and then time once again. And they have all these different blobs of different points of channel or elevation, right? So viscosity is going up here, and if I zoom it in, you can see this is a log scale. This is 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth. So the highest viscosity, the most resistant to flow of anything, is that flow 1A flow front all the way up here at 10 to the seventh, right? And over time, as time goes on, it gets more viscous. More viscous is up, and so more viscous. And all the other vents, here's events between 5,300 feet elevation and 5,900. They're also getting more viscous over time. The ones that between 6,000 and 8,000 are also getting more viscous through time, right? And you can see overall, the further uphill you get, here's the actual vents that have the lowest viscosity, but then over time they also are getting more viscous. So everything is getting more viscous with time, and with distance from the vent, it's also more viscous. So the long and short of it there is that viscosity, as a result of the crystals and the gas, is what's causing it to kind of get all gummy and the eruption be doomed to end at that point, you know, because of that. So here's a little clip from that paper, just because it seems really relevant right now. Principal causes of changes in viscosity and yield strength are related to changes in temperature, gas and bubble contents, concentration of solids, and plastic clots. The major changes at the vent are probably related to changes in gas and bubble contents and concentration of solids, because the vent lava at, in their case, 1,140 degrees Celsius, we're 16 degrees hotter today. The vent lava was frothy and had about 14 to 21% volume concentration of those microscopic crystals in April 2nd to 3rd. So by April 13th, 10 days later, it had gone from 14 to 21% up to about 27% of the volume with crystals, while still being frothy. So they say that a 13% change in that concentration of crystals at this temperature would probably increase the viscosity by a factor of 2 or so. And thus, the parent viscosity of the frothy lava at the vents increased by a factor of 10 over those 11 days, April 2nd, April 13th. So it seems like, you know, these are all like kind of tiny things, but that's a factor of 10 change possible in 10 days over the course of this eruption. And that's a similar pattern we're seeing now. We don't have the hard numbers. We have had reports USGS saw crystals when they're looking at the samples, and we just have to get the numbers after the fact, but the pattern seems to be the same here. And that's why it does not seem surprising as this level of research done in 1984.
Quick question. What is the source?
Sorry?
The source for that one?
This is Professional Paper 1350. And this is Chapter 57. Lipman and Banks, a.a. Flow Dynamics. It's just that paper that we've covered little bits of. It's fantastic. It's really comprehensive, all kinds of aspects to it, and we'll keep covering it as eruption goes on, and, you know, even after it ends, we can look at some of the details in there. But trying to keep it relevant and not give a full-on academic lecture here. So I'm trying to get snippets one bit at a time. So enough of that, and we'll move on to some more of the visuals. There was a release today, December 8th, from the USGS. They included that thermal map and 3 videos, 2 of which I was showing you little clips from, and we'll show you more that Dana's posted. And then 1 which is showing a lava boat. So let's look at that video. Here it is. Let me turn off this wind. And right there is that lava ball chunk of one of these channel walls or something that, because it's coming from upslope, it's closer to the vent, is likely not very dense, because remember, the closer to the vent you are, the less dense you are, the more frothy your lava. So it's able to float in the channel, but it's getting coated in other layers of lava as it goes down. And you can see that it's quite sizable. And in this case, you just see the one, but there's other chunks in there that are not as easily seen, but a whole bunch of stuff floating down at once. So what I'm going to do now is I'm going to switch to some of the photographs by Andrew Hara, photographer in the community. He's been sharing, working with Paradise helicopters. And so these are a set of images from yesterday, actually, but still are going to be very educational to illustrate our point. So mahalo, Andrew. Andrew's on our intro video. Those of you guys who haven't seen him yet, he's been around contributing since 2018. So here's a view looking down at that channel, and there's one of these lava boats, lava balls floating down. You can see how large they are, and they're actually close to the full width of the channel in this particular case. Right? So you can easily see how these could form blockages. That's one view. Let's look at some more. Here are some longer ones. These are easier to imagine being the banks of a channel that the lava level dropped and then the edge just caved in, and you have these long chunks of channel bank. So it can come in different shapes, and this is before they get all the way coated in lava and they become rounder and rounder over time that way. This is a fantastic image. Reminds me of that famous Katya Kraft Pele dancing photograph. Good job, Andrew Hara here. And what I wanted to point out, besides the obvious beauty of this, is a lot of lava balls in here. So there's one there, there's one there, and there's one there. A whole bunch in there. It's actually a whole train of them, right, all through here. And they're described this way in that same paper we just described, question paper 1350, chapter 57, that they come in clusters, because what happens is the whole bank of the river will collapse all in one area all at once, and you get a whole bunch of chunks all coming as a cluster down a channel. It's not just like one once in a while, then another once in a while. They kind of come in these clumps. So if you have a big clump of these lava boats coming down, and you see something like this, where the lava channel started to crest over and form a little tube or a little constriction, and then clearly all that stuff can't get through here, and it's going to start piling up, and it's going to force an overflow. That's why these things keep happening. So it was a good question from Arthur series that we've been discussing for the last few days about the lava tubes forming and channels and constrictions and how that could happen. And so that's been happening, and that's helped the whole overflow situation here. So there is one example of that. Another example there of one of these constrictions, lava going into an area that's tubed over and then having to reemerge out the other side. And clearly any load in the channel is going to inhibit that as a problem. In a wider angle view yesterday, showing areas like this right through here, you see that big gap in the river. It's actually going through a tubed over spot through there. So the more tubes forming, and one other thing is worth noting is lava level has to be somewhat stable, and actually if it's dropping, it's easier to form a tube because it can form a crust, and the flow can drop within it rather than it varying higher and lower, right? So that's the other thing, is once you have these blockages and tube sections, then all those surges from the top of the channel, they can't all fit the surge of lava all at one time. So then you force more overflows as well, more drainage, more collapse, more boats, and you see how the whole thing just cascades from there. I'll stop showing those images from Andrew here. He's got a whole bunch more that are amazing, so you can check them out. But for now, I'll move on to looking at some webcams. Here's our webcam, the M9 that we were looking in yesterday. So there is that flow front. Actually, right in here is that flow front. We'll see it's probably going to still be glowing at night for likely a couple more nights, I'd say at least. Probably a little longer, depending on how big an area you're looking at. But it's no longer being fed by lava, so it will cool off and dim out at some point. Sooner than later. So there's the view M9. Let's scroll it down here, and maybe I'll check. Oh yeah, we are current time. So let's look at all the other webcams here. Scroll it up, freshen it up here, and our M8 still fountaining slightly above that rim. This is the M9 once again. Just looked at. M5. We've in the past shown this spatter cone building up from the side. You see the fountains presently are not visible over the top because the cone is grown and the fountains are presently lower. We'll update this in the next few days as well. There is our M6, still showing that eruption site off in the distance. The channel here in upslope, not showing as much lava, so this might be an interesting one to look at in the next few days too, as the flow is changed up in here. And otherwise, there's other views from the south from Volcano and Maunaloa, MK2 camera. And there you see that flow is just up through here. Really don't see any red anywhere else in this downhill section on the surface. So interesting to see that change, and really fascinating this ending phase as it appears to be of this eruption here. So I thought I would show the whole evolution of this channel. So this is going back to when we first only had the MK camera. It's a little blurry, but it shows you the first flows coming down. There they are. We still have Fissure 4 active here on the left. The flow is still streaming down, lots of different channels at the top, but mostly staying within those channels. Start seeing branching here. This is December 1st, and kind of jumping through time as the views allow us here. We start seeing more outbreaks, branches off here, and the branches are getting higher and higher and higher. And that's what's leading up to this final overflow and retreat up the hill that we saw. So a combination of the viscosity and the banks and the lava boats, and then finally the reduction of lava as well, really taking it to the next level. So there's that sequence. We'll show that again tomorrow. But M8 once again there. Let's keep going. So looking at the VOG, here is the VMAP forecast showing from Kilauea, VOG, and Pahala, Na'alehu Ocean View area, and from Maunaloa, essentially coming towards Kuala and splitting into North Kona and South Kona, all affected and likely even wrapping around here a little bit too. So VOG still a concern, especially evident on the west side from the forecast. We can look at the EOH map. Let's reload it to get the data points on here, and usually this does not show us a whole lot of anything but green. So the Kona stations are in a green, but they're showing the numbers here too. That's 49 is getting close. So here's a history for Kona, and you can see it actually coming into the yellow a few times over the last day here. But on a borderline, yellow and green. As you know, we like to look at purple air for the PM 2.5 10-minute intervals, and now you can see that the whole Kona side is still showing impact at shorter time scale. And so definitely VOG impact there. Okay, in the national park, all greens. So most of that lower emission from Kilauea, even though the VOG is coming from there, it seems to be less so, and Maunaloa is the higher volume to be concerned with there. So that is the VOG update, similar to yesterday. Earthquakes, similar to yesterday, even less, but still occurring in similar places around the caldera and the Northeast Rift flank, but really down a whole lot. And Kilauea still has some, but the largest one was at 2.1, and it seems to be still doing interesting things, but responding to Maunaloa. Maunaloa is changing again, so Kilauea will likely be following at some point in some way, and we'll keep an eye on that. So on Maunaloa, looking at the signals, here are earthquake rates. So earthquake rates are still down, and in fact, maybe dropping even further. Let's skip through the bigger timescales. There is a last week still concentrated. I want to get down to the tilt plot. There is a tilt plot for the last week. So you can see this deflation as magma is leaving the summit area, right, and feeding the eruption. We mentioned that this little earthquake that occurred shallow under the summit, and it looked like it was just some localized adjustment. But the interesting thing here is right here within the last day, when we've seen these changes at the vent, we now see the volcano start to reinflate again. Very little, just barely coming up here. But this also would suggest that the magma is starting to back up and not come out the vent. And typically when eruption ends on Mauna Loa, like you immediately start to see it reinflate, like immediately. So that could be a sign that it's starting to build up underground rather than get it out the vent as easily anymore as well. And that's part of that whole evolution of the system and eruption. So something to keep an eye on there. It's not like it's climbing up super fast, like it's a whole new batch of magma. And if it was a new batch of magma, you'd expect the volume coming out of the vent to be going up. So if that were to happen, we can say that, but everything is pointing in the opposite direction, seeing the lava flush out of the channels. Seems like, in fact, this is built up underground because the vent is closing off. So that's the picture for the whole last month, and the GPS still showing that distance contracting across the caldera and dropping downwards as well. So that's also consistent with it still feeding the eruption and not something else coming in, just backing up because the outlet is reduced. Okay, so let's move on from Mauna Loa to touch base on Kilauea. And let me reload this because it's 4.5 old now, but that's the image from Kilauea, and it looks like it's just a little pad right there where it's the brightest yellow is where the freshest lava has been oozing on top of that hardened crust. The crust is looking pretty stiff there in that backside. So there's the last 24 hours of how that actually looks cycling through. So only in this front part of the lake is there any action. The backside seems to be hardened consistently, and this is the side that's closer to the vent. And so the lava come up underneath this west vent complex, go over to the west vent pond, and then turn and go over this way. So that pathway is still there likely, and this is why this is the end of the pond. It's showing that extra activity, lingering activity there. The wider angle view from a KW camera over the last 24 hours. It's been kind of rainy today in Volcano. So you see some of the steam come through, and you see last night, well, this is actually this is from 2 nights ago, so let's give it fresh here. And last night you see those spots of glow coming in there, and this is a little bit of glow visible, and then a whole bunch of steam coming through across the day. Maybe more useful to look at the V1 camera. Let's pull this one up. Here's from noon today. Can't see a whole lot in that daytime. Looks like everything is actually hardened and still at that point in time. Now it's getting dark, so let's reload and see what we see. And there, that little pad of lava by that outlet of the vent, just over here. And if you look at the plot of lava depth, they're saying the lava depth actually increased by about 1 meter. It's probably pointing, the laser's probably pointing to this end of the lake, and this is what's growing, so it's thickening, piling lava on top of here, but it's not really fair to say that this whole lake is filling by a whole meter if it's just this one end of it now, and it's not really flowing, circulating. So we'll wait and see what happens with that. Kilauea's update here from this morning, December 8th. No significant changes noted. They say the active part of the lake's risen 1 meter, and otherwise nothing else is new here. Last emission rate 316 tons per day. Everything's stable. So that is Kilauea there. Before we switch to our questions, Dane, wrap up our information sharing here, I want to do a little community segment and mention that this Saturday, December 10th, we'll be in Hilo at University of Hawaii Campus Center Plaza, 10 a.m. to 1 p.m. as part of the Hilo Makahiki by the Resilience Hub Network and Vibrant Hawaii. And other sponsors as well, the county, HPM here. Activities, demonstrations, these are all the groups that are working towards preparedness for an eruption, for an earthquake, for a hurricane, for a flood, for any of these pandemic, any of these crises that really benefit from community ground up action. Dan, you want to jump in here and talk about this a little bit?
Yeah, I mean, for anybody that's not familiar with the concept of a hub, when we're talking about these resilience hubs, it really started 2018 with the efforts that were made in order to respond to that eruption, right? Community efforts. And that was under the umbrella of Pu'uonua Opuna, which was also just reduced down to being called the hub, right? And it's where everybody kind of contributed and went to unload after, all the crazy eruption things that were happening in Leilani and then Kapoho and everywhere in between, right? So this is trying to take the concept of a hub, which was ad hoc at the time. It was all done on the fly, and asked, what if we set these things up beforehand with preparation, with cooperation from the county. So then when the time came, we just had to flip a switch and activate them. Right. And that's kind of what this festival is all about, is the beginning of this whole resilience hubs and trying to get everybody involved and trying to get it all out there. Right. The Maki, this will be the third Makiki?
The third Makahiki, yep.
Yeah, the third one. And we'll be in Hilo, so come check us out, and we'll be able to talk Maunaloa or Kilauea or anything else volcano related if you're in town.
Yeah, so yeah, absolutely. Come check us out. So that's one event on the calendar that I wanted to note. You also want to mention, we also have events ongoing at Hawaii Volcanoes National Park. We haven't covered this as much as we usually do because of Maunaloa's eruption. In fact, we missed the After Dark at last week, unfortunately, but what can you do? So there are still dynamic changes to the schedule because of the eruption, but there also are a lot of other events. So there was a Holidays at Kahuku last week, Saturday. Kahuku is still open Thursday through Sunday, although closed New Year's and Christmas Day. And coming up, December 10th to this Saturday, 7 p.m., Kamehameha School's holiday concert in a national park. And there's another concert, I'm going to scroll down here, John Keave and Naleo Manu on Wednesday, December 14th, 7 to 8 p.m. in the ABC Auditorium in a national park. So a couple of holiday concerts. There's also more stewardship. Dick Hirschberger is still doing his historic reenactment of Dr. Jagger. And there are other ranger walks up there, including Olelo, Hawaii, Ranger Kama Obrero on a special guided tour given in Olelo, Hawaii, in Hawaiian language for those who would like to partake in that. So one last thing, and that is that also this Saturday, December 10th, a couple days from now, there's an in-person meeting planned at Na'alehu Hongwanji in Na'alehu Karu. This is to do with the Kahuku Pohui public meeting area. This is that parcel of the national park that was just acquired that's downhill of Kahuku, all the way to the ocean, including Pohui Bay here, which is a endangered turtle nesting site, and overall amazing place. So because of access issues and recently fought a fire down there, so there's all kinds of stuff going on, and there's a public meeting to discuss plans the park has for access and everything that's there. So that is also going on, and that is the calendar updates that I've been putting off for a while, but we're only 2 days away now. I thought we needed to put this out here as well, since it is right upon us staying here. A couple of days away till the Makahiki and these public meetings. So let's turn to some questions, some thank yous.
All right, yeah. First, I'd like to thank everybody that tuned in today. We rely on viewers like you to help get the message out there and get the spread. Algorithms don't exactly love us, but being able just to hit a like, subscribe, all that kind of stuff, it really does help get it out there to more people. So we appreciate you guys. We also contribute all of our stuff onto hawaiitracker.com. So if you're looking for a chronological order of what we're updating, because we do a lot of text posts on the Hawaii Tracker Facebook group as well, check out hawaiitracker.com and we'll have those as well. Do want to start out by thanking I.K.A. Hawaii for helping us keep an eye on Maunaloa and keeping everything, like we got to be able to see the thing, right? So they have offices in Hilo, Kau, Pahoa, or Puna, and they do everything from cataracts to LASIK to same day glasses. So definitely check them out. Also want to give a quick shout out to the County of Hawaii for the Vai grant, helping keeping this type of content going. All right. We got a bunch of questions. I don't know if we're going to get through them all. But we got some to make up for. Yan Zhao asks, this was from yesterday, how long will it take the lava to harden up and cool down? Like, let's say the eruption came to an end relatively soon.
It's all depends on the thickness of the lava. So in some of the areas where it's overflowing and it might be only up to, let's say, a meter thick, a yard thick, then it can harden pretty fast. It can stay hot for a little while still. The thicker the flow, the hotter it stays for longer, right? So down at the actual front of the flow, where it's maybe 40 feet thick at its thickest point, that's likely to stay hotter for a lot longer. So even after the eruption's over, when the rain goes through there, you might still see it steaming, or in a cold night. I'm not sure exactly what we'll see there, but will be hot for a while. The a.a. flow itself is mostly hardened as far as its shape's going to be. The Pahoja flow is hardened pretty quickly as well on the outside. So as far as what you see visually from the air or from the cameras that we have, it's likely to look pretty similar there. Did I answer the question?
Yeah, I think so.
Yeah.
Um,
Let me know, Jan, if you like more.
all right. Josh asks, it's similarly, how long does the glow last after the magma stops flowing? So lava stops again, how long is it going to be glowing?
Yeah, another good question. It depends exactly what it is, right? If it's the actual lava itself, the actual flow itself, then it will glow for less time. But if it's that, like a lava tube that has remnant heat, or some crack up by the fissure, by the vent, that could remain hot for longer and glow just from this being hot enough to glow, but not hot enough to produce lava. If that makes sense. Like a slightly different temperature range there, so you can get glow a little bit longer. But let's go back to 2018 for our analog Dane, and we saw the vent kind of drain out. It seemed like it stopped for about 3 weeks, and then it popped back up for a couple days, like a little extra burp, where it glowed again briefly, and that was the end of that, right? But there really wasn't any glow within days, I'd say, yeah. In days, the glow stopped. So that might be my best answer, within days.
And also one of the things about that is with this giant a.a. flow, you'll have void areas that you'll be able to look in further than others. And you can see in these little holes, the voids that's insulated and able to retain the heat, it'll glow longer than the surface area that's exposed to the winds and all those kinds of things.
For sure.
All right. Next question, trying to get through a few of these. Regav asks, do these changes mean that all the lava inside Maunaloa is almost finished? Could the eruption migrate elsewhere if Fissure 3 were to stop?
Yeah, so I think the first thing to answer is that any eruption does not empty the volcano of magma. It will siphon off, somewhere between 1 or 2%, and I think we saw maybe up to 10% in 2018 might have been the upper limit, 10-11% of the actual upper chamber might have been erupted out, right? So my analogy to that is kind of like that champagne bottle or soda bottle, pop bottle, right? If you shake your champagne bottle and you pop it, and that erupts all this gas and all the liquid comes flying out, the bottle you have left behind always has some liquid in it. That flat liquid that doesn't get flushed out is still in there, right? You have to leave some behind to have it be the source of the gas that escapes to throw the other stuff out. So you never empty the volcano entirely. That's kind of one part of it. So absolutely yes. So it's more about that pressure differential of being able to get out rather than the full volume and it being emptying out, right? If it was pouring by gravity, then it might be the situation you're imagining where you really can empty it to the point of gravity allowing it. But usually it's more of a pressure equilibrium kind of thing. And as the magma gets stickier, not just at the surface, but it's happening in that source, in that whole blade underground, that whole thing is getting gummy. And at some point, it's just going to gum up enough that it's going to be able to repress. It looks like it already is repressurizing towards the summit, and it might do that for however long it is to the next eruption. But it does not seem likely that Fissure 3 will migrate elsewhere, likely because it's been stabilized in that one spot for so long. That's what history tells us. Once the migration usually happens early on in a sequence. And furthermore, all the geophysical signals are not showing that additional injection of magma coming in. And that's what we worry about, is like if it's like a changing because of some injection coming in of like a two-phase kind of eruption, right? But we don't see signs of that in the monitoring signals. So that does not appear to be what's going on. It seems to be, relatively speaking, a slightly smaller eruption the 1984 version we had, right? As far as how far it propagates down a rift, and we'll have to see ultimately how much lava is calculated that got put out. But it seems like overall, maybe the duration, the timeline is slightly different, but yeah, maybe we'll just leave it at that.
All right. Thank you for the question. Next one is from, let's say, Matt. Matt, that's an interesting one. What's your biggest surprise or learning, or the thing you learned the most from this event?
Well, I mean, I think the whole of it really, like, I mean, I think that one paper by Lippman and Banks from '87, that's that chapter 57, the question paper 1350. That really, it's something that I read before, but it was a lot more abstract. Really, it's, you know, really just seemed like theoretical, and it's a whole different thing to see it actually in action and be able to follow the pattern and see how much sense it all makes, and how similar, really, you know, maybe that's the ultimate story, is how similar this was to 1984. I mean, the fact that it came out on a northeast rift in the first place was a big surprise, right? I mean, we thought it might be slightly up in that summit region, and, you know, it's kind of borderline. It really didn't escape that far from the summit, but it did go in a northeast rift to that uppermost area of it. But so yeah, that was really interesting, how similar to 84 it was, but then also how different and not propagating any further. Right. Otherwise, the actual flows coming down a north flank, following that similar pattern that's been described several times now. So really cool to see that in action, and I think we'll learn a lot more from the science of it. You know, we'll probably be excited about the science of it for a while longer, because, you know, we don't really have a whole lot of the numbers coming out yet. Everything's being crunched and analyzed by the scientists, a whole cohort of researchers there. So we'll learn more as time goes on, and more the firsthand living through it, following along, tracking it as we go.
Right. For me, it really comes down to just the response and everything along those lines, to see everybody get a real world practice run of what a Maunaloa eruption will look like, from HVO to civil defense to the random civilians to the media to everybody. Right. We just had a real world run of Maunaloa, and it was a very it was set on easy difficulty, basically, especially for a rift zone eruption. Right. If it's just in the caldera, then it's just in the caldera, but we're talking a rift zone eruption here, and to just do this dry, not even a dry run, like a real run, but to have nothing really in the sites, you know, in the where it's bearing down, and we're just like waiting type of thing. So yeah, it's really interesting so far, and we'll see what the final stages have for us.
Yeah, one thing certainly is true. We'll all have a lot more experience at Maunaloa erupting than we did before, and that can only be a good thing as far as education and preparation and awareness and people taking it seriously, right? So that's something that harder to convey when a volcano hasn't erupted for 40 years. You're like, but really, you need to get ready. And you're like, well, really? Now it's more obvious and undeniable, right?
Yeah.
What the volcano can do.
Right. And we'll be ready for the repose period and what comes after that, you know, type of thing. It's always looking forward to the next one.
Yeah, it might be worth mentioning just real quick, throw it out there and come back to this at some point, but I think the shortest time period between rift eruptions is on the order of 3 years. So, right, so we erupt in a rift again. That's historical, a very short, very small historical data set we have. That's the maximum.
All right. Well, on to the next one. Yvonne asks, are the crystals mostly olivine, or is the composition already changed to other crystals showing up?
So there is olivine. A lot of the olivine is carried from before the eruption that's growing in the rift area. So what they're seeing a lot of is plagioclase, augite, pyroxenes, cyanopyroxenes, and pigeonite. Like those kind of things are what's growing in there as well. And yeah, some olivine too, of course. But yeah, the long needle ones, those are all the plagioclase crystals for the most part, rather than the olivines that I showed you guys the images of. And obviously a long blade of crystal is a more of an inhibition to flow than a rounder, more equant one. Right? So those ones matter, especially when I get super long.
Right. All right. Well, I think we've gotten through most of the questions. Let me check one more time. What, a little over an hour here.
Yeah.
So I think that's...
Yeah, I can do a couple more if you like. I see Yvonne asked about the tilt spike. That was the earthquake, Yvonne.
Yeah.
There was an earthquake,
That's that one.
2 days ago. Days are running together, but there was a shallow earthquake that occurred, and we're looking at that as possibly a settling event or possibly a sign of some renewal, but ultimately it seems more like settling. But it's all related, of course, right? It could be a little bit of both. Kilauea has larger earthquakes, and yeah, that is because magma movement is going on there. So that's a comment I can confirm there. That's what Ken told us yesterday as well. It's more interesting to look at Kilauea's signals now because it's responding to the changes in Maunaloa. Maunaloa is just following a game plan.
Right. There's still a question mark in Kilauea what it does now. All right.
Let's see. I thought I saw one more. Any chance that flow is just cresting over and creating a tube? That's from W. Steve Stevenson. If that's the case, we'd see that lower flow front still advancing, and that's something that would come up on the thermal signals as well. And that's why the thermal is so useful. It can pick up that heat through the tubes even as well. So that could have been the case. Like, that's something that we've been discussing, and that's something that happened in the 536 flow and that 1833 flow both, where there was a later stage of more pahoehoe that did form tubes and eventually did change the nature of the eruption. But that doesn't seem to be what we're seeing here. So that is possible, but does not seem like what's happening in this particular case, given the evidence we're seeing so far.
Yep.
All right, that might be enough.
Yeah, I think so. We're trying to get these streams down a little bit in time, and we still can't break that 1 hour barrier, really.
Well, I feel
to keep it under
for yesterday and cutting out, and we probably lost 50 minutes of the questions from yesterday, so that's all right.
Yeah. All right. Well, thank you everybody for joining us. If you are planning to go view the lava, I would advise to maybe do that sooner than later, especially with these high fountains. I mean, that's something that's going to be visible from the viewing area and would be a sight to behold type of thing. And if it is going into waning stages, then the views are going to not be as vibrant each night. So yeah, I think that does it for me. We'll try and come back tomorrow, you think?
Yeah, I think we'll give it a shot. I mean, it's interesting, it's dynamic, it's changing, and we'll have to see about the weekend because we'll have that event on Hilo on Saturday, and take a day of rest as well. So we'll see about the weekend and how fast things are changing. And we're also working on more interviews, so we'll see how that goes. And we also want to take our own advice, and we, depending on the forecast here, we'll have to check into it after we're done, but we may head up the mountain tonight to pay our respects.
Time to check that new camera out and see what it looks like.
Yeah, so if you see us, give us a shout. And
right.
Otherwise, we'll see you back online tomorrow. From HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everybody.